Welcome to another educational segment by the QTV. My name's Daydream Wendachare. Today we're going to be discussing chemistry, and the topic under discussion is the particulate nature of matter. Matter is anything that occupies space and has weight, but some books would rather say anything that occupies space and has mass. So, since we have described what matter is, we're now going to talk about the states of matter. We have three states of matter, namely solids, liquids, and gases. So solids have got a fixed shape and a fixed volume. Solids have got a fixed shape and a fixed volume. To add on, solids are incompressible. The reason why solids are incompressible is because they have, I'm going to draw this diagram. It's because solids have got particles that are closely packed together. And the other state of matter is liquids. Liquids, unlike solids, have got a fixed volume but an fixed shape. This means that liquids are slightly compressible. The particles in liquids are closely together but not closely packed as in solids. This is why liquids are slightly compressible. Then we have gases. Gases neither have a fixed shape nor a fixed volume. Gases are the ones that are compressible because of the fact that they do not have a fixed shape and a fixed volume. Apart from this, we're now going to talk about the changes of states of matter. We have When we talk of the changes of states of matter, we're just talking about the physical changes that take place when a substance absorbs or loses heat. So some changes of states of matter that are there is one, heating. When we talk of heating a substance, we talk of adding heat energy to a substance. And then this causes it to change its physical state. Examples of heating, we have melting. Melting is a changing of state from a solid to a liquid. So I can indicate it here, from solid to liquid. Melting has got a specific temperature that occurs. So this is what is known as the melting point. The melting point, on a separate note, can be defined as the temperature at which a solid is converted to a liquid. And usually when melting occurs, a substance absorbs heat. So aside melting, we can also talk about evaporation. Or before I even go to that, melting, we can give examples of melting. We have when an ice is converted to water, when an ice turns into water. That's an example of melting taking place. So another physical state that occurs is evaporation. Evaporation is simply the change of state from liquid to gas. So during evaporation, what happens is the liquid is going to be converted into a gas. So as the liquid is converted into a gas, an example of evaporation is boiling. Boiling is not necessarily evaporation, but I'm just going to give it as an example. At the end, I'm going to show the difference between evaporation and boiling. Another change of state is sublimination. Sublimination is simply the conversion from solid to gas and vice versa, gas to solid. So sublimination, we're talking about converting a solid to a gas and a gas to a solid. And then examples of sublimination, examples of some substances that sublimate, we have iodine and carbon dioxide. Yes, so from here, we have talked about the physical states, physical changes in matter. We have heating, and then under heating, we talked about melting, which is from solid to liquid, and then the temperature at which a substance is converted from solid to liquid is known as the melting point. An example of melting we have given when ice is converted to water. Now when we come to evaporation, evaporation is simply the conversion of a substance from liquid to gas, and an example is boiling. And then we've also talked about sublimination, which is from solid to gas. And then we've also given examples, which is iodine and carbon dioxide as substances which can sublime. Then nextly, we're going to talk about the heating curve. The heating curve simply shows us how these substances are converted. So we have, as you can see here, there is the y-axis showing us the temperature and the x-axis showing us the time. So this, the curve here from A to B is the solid part. And then from B to C is a mixture of solid and liquid, but some books will indicate solid to liquid. Generally, it's just a mixture of liquid and solid, which is, if we're talking of ice, there's some ice and water in it. And then C to D talks about the liquid. The liquid itself, that's when it has now fully converted to water. And then D to E talks about the liquid and the gas as evaporation is taking place. And then E talks about how it's eventually converted into a gas. So from A to B, this is just the solid. And then B to C is showing us melting. So this can also be referred to as the melting point, because it's the point at which the solid is being converted to a liquid. And then as it is the liquid here, we also have evaporation taking place, and then this is what is now referred to as the boiling point, because it's showing us how the liquid is being converted to a gas. So from here, this is the boiling point, and then the gas is up here. So at this point, we usually have a temperature of 0 degrees Celsius. And then we know that this is a point that shows us the temperature of 0 degrees Celsius. And as I mentioned earlier, the time also is also there in minutes. So lastly, I just want to mention on the difference between evaporation and boiling. So for evaporation, usually evaporation can take place at any temperature and any time. So for evaporation, I'll just indicate any temperature. But for boiling, it's going to require a specific temperature for a substance to boil, meaning that the temperature required is what we referred to as the boiling point. Then for the boiling points, different substances have got different boiling points. So an example is the boiling point of water is 100 degrees Celsius, but the boiling point of water also differs to the boiling point of ethanol, which is 78 degrees Celsius. That's why we're saying evaporation and boiling are two different things, then evaporation takes place at any temperature. And then we can also say evaporation is slower while boiling is quicker. The reason why we are saying evaporation is slower and boiling is quicker is, I'll take for instance, you get a container, a pot of water, you leave one outside for some time, and then you put the other one on the stove to boil. You are introducing heat to it, and then you're going to discover that as the water is boiling, being converted to a gas, it's going to react much quicker as compared to when you leave it outside, because no temperature is required for that. That's why we're saying evaporation is slower and boiling is quicker. So from this, I'll just want to sum up everything by saying evaporation and boiling are both involve the conversion of a substance from a liquid to a gas, but boiling and evaporation are different. This is the end of the video.